We are going to go ahead and get started today. So we are talking about building a Wi-Fi lab, and I'm a big believer in utilizing experience as a learning tool. And I'm going to explain to you some of the reasons why I'm a big believer in that. I don't just believe in it because I think it works. I don't just believe in it because it's historically been something we recommend when learning technologies or something like that. But it's because there's actual research that shows that we retain information significantly better when we actually enact, when we do something in relation to what we're learning. And so labs are very important for that reason. But at the same time, I know that it can be expensive. I mean, if we all had our dream, we would have multiple racks with dozens of servers and switches and routers and APs from multiple vendors and controllers and cloud accounts. And, the problem is that runs into tens of thousands of dollars, possibly hundreds of thousands of dollars, depending on what you're trying to accomplish. And so what I want to do is really not recommend specific gear so much today, though we'll look at some, but to show you what to look for when you're picking gear that you can use in your lab, and then how you'll be able to get out of that gear what you need, how you'll be able to actually enact some learning experiences that help you understand the technology as it would be used in an enterprise environment, possibly with different gear, but in that enterprise environment. We want to have some experience with the features and capabilities that are available to us there. And so that's what we'll be looking at as we look at different hardware and so forth. Now, as we do start into this process, we're going to talk about the benefits of lab work. First of all, I'll spend a few minutes sharing with you some of the research that shows why you want to get experience. And then we're actually going to do a tiny little exercise, but we're going to do a little exercise together that demonstrates to you how getting into the lab really helps you master complex material. And there's no question that Wi-Fi is complex material. One of the things I never do to someone that's beginning to learn this stuff and they're just coming into the Wi-Fi space, I never tell them, oh, don't worry, this is going to be easy. I want them to have a realistic view, because if you tell them it's going to be easy and they get about an hour or two into, say, a CWNA class, they're probably already beginning to pull their hair out and look like me. So what I want to do instead is let them know it's going to be challenging and interesting. So that's the way I present it. And the reason I do that is because the interesting part will hook them. The challenging part is real. If you really want to understand this stuff. Now, if you don't want to understand it and you just want to know, okay, I click here and I toggle this switch and then magically it just works, then fine. You don't really understand it. You also won't be a good troubleshooter. You won't be a good analyst. You won't be good at designing wireless networks. You won't be actually good at doing the stuff that we need people to do related to our wireless LANs, because you'll just basically be someone who can click the right thing based on a vendor recommendation. And vendor recommendations aren't always right. So we need to know what is right and have the ability to pick the right options. That means really understanding this stuff. And that does mean getting in there and working with it. Now, we'll also talk about some low-cost AP solutions, and not specifically, again, going through the list, because we could spend 3 hours today just looking at different APs that are low cost and what features and functions they have. What we're going to do instead is look at one example, and I've intentionally chosen one that fewer people have heard of, so that you'll see that there are things out there you might not have been aware of. So we're going to look at one, and we're going to look at what are the features it has, what might it be missing, what does it give us the ability to do in a lab scenario, and things like that. So that's the focus. What are we looking for? And then the same thing with spectrum analysis and protocol analysis. So we'll gain an understanding of some of the tools that are available there. And then I'll share with you at the end how you might incorporate this new large language model stuff into your learning process. I hesitate to just generically say AI, because AI has been with us forever. This is kind of a pet peeve of mine. what happens with AI, which of course was dubbed in 1959 with the Dartmouth Conference when they came together to discuss the concept of artificial intelligence and how to begin researching it more. And the reality is that over the decades since then, and it's really astounding to think about, but we're just a few years away from it being 70 years into the development of AI. And the reality is that over the decades, many things that were discovered in AI research just became part of what we did in our applications all the time. You know, the example I like to give is some of us are old enough to remember when we first started seeing OCR scanners come on the scene in the early 1990s. You might remember those handheld scanners that we plugged into our either serial or parallel port on our computers and then installed a special driver, and then we could move it over a sheet of paper or a page of a book. We literally had to physically move the scanner. It was a handheld scanner ourselves. And then you'd load the image into an application and you could do OCR. It was pretty good, but it might be, 3, 4, 5 minutes for it to OCR one page. And now today, when you use OCR, you scan with sometimes automated scanners, hundreds, thousands of pages. And then Adobe Acrobat and other tools can scan a page per second or so of doing OCR operations. Well, object character recognition is artificial intelligence. That's what it is. So, the people that say, oh, AI really didn't do anything for us until large language models came along. Well, in a large part, large language models were dependent on OCR to be able to get all of our printed text into a digital form that they could use to learn from. But the point is that much of AI just becomes embedded in our day-to-day practices, and we don't really realize it's AI. We really didn't make a huge leap forward 3 or 4 years ago when the LLMs came along. We simply have a new AI technology that we can utilize now and sometimes be misled by. And so I will talk about that when I talk about using AI in the lab. But it is available to us through large language models, and I'll look at some strategic ways that you can use it in order to make sure you're getting the right information. Now, let's talk about why doing lab work is worth it. The psychology of doing it. There's been a lot of research over the years into this, and one of the interesting things is that as we get older, like myself, then our recall memory performance degrades, and it depends on the type of encoding that was used to learn the information. So, we have verbal encoding, we have active encoding through mental exercises, and we have active encoding through working with an external object, external to ourselves. And depending on which one we're using, the free recall degrades differently, but it does degrade as we get older. But most of it doesn't happen in a very significant way until you get post 50, and then it continually gets worse and worse. These lines can be a little bit misrepresenting, though, because it makes it almost look like, when you reach 85 or so, that your free recall is next to zero. That's not the case. It's this. These lines represent the amount of degrading. It's better shown in the image on the right. And here's the interesting thing. You'll notice that at the average age of 25.7, everything's a little higher, right? So whether it's verbal, acting with no object, or acting with an object. And again, acting with no object means that you're doing mental actions. You're imagining that you're doing it. Kind of like you've heard of athletes visualizing themselves, catching a football and scoring a touchdown, or kicking a football and scoring a goal, depending on what part of the world you're from. The point is that acting with no object is that mental visualization. And then acting with an object would be actually going out and catching the football and then running, or kicking the football and scoring a goal. So these are, how do you remember things? If it's just verbal, that means someone just says it to you. If it's acting with no object, it means that you're imagining doing something with that knowledge. And if it's acting with an object, you're actually physically doing something with that knowledge. The big thing is that even at 25.7 years of age, a nice young person there, you can see a massive difference in the free recall capabilities. Then you'll notice that it goes down for all three as you get older. And here's the key, though. This is what I want you to notice. Notice that at 69 years of age, you're still better than the 25.7-year-olds for either verbal or acting with no object if you learn by acting with an object. In other words, yes, the younger folks are better than us when acting with an object, if we're getting closer to that 69-year mark, but we're better than they are if they're acting with no object or if they're just doing verbal learning and they're just getting a lecture, right? So the point is, even though the left image shows that things degrade as we get older, the reality is it hasn't degraded so much that if we're doing active learning, we're still retaining as much information as a 25.7-year-old who's just doing verbal learning or acting with no object. So that's good news, right? As you get older, you want to do more and more active learning. That's the moral of the story here. Now, an individual by the name of Kolb wrote a book all the way back in 1983 called Experiential Learning. Experience is the source of learning and development. And he did update that book in 2015, actually, the second edition. So not too many years ago now. And that second edition was published by Pearson, if you're interested in looking up the book. And he presents in there the modes of learning: concrete experience, reflective observation, abstract conceptualization, and active experimentation. And the suggestion is to flow through this process. So the concrete experience is you're doing something and then you reflect on it, you observe what your experience is, and then you abstract that out. This would be kind of like saying, okay, so this is reality. Then you experiment based on that abstract conceptualization, which leads to another concrete experience. You reflect on it, and then you get to, okay, now let me modify my previous thinking. This is actual reality. And so as you go through that process, that is experiential learning. It's the way we go about learning through experience. And this is important because learning through experience is the most effective way to retain information. John Dewey in 1938 said, "I take it that the fundamental unity of the newer philosophy of learning, is found in the idea that there is an intimate and necessary relation between the processes of actual experience and education." So that's all the way back in 1938 when John Dewey was putting this forward, before we had much of the modern research that we have today. Experience enhances remembrance. So we're not going to talk about every method of encoding, but we have semantic encoding and we have enacted encoding. And enacted encoding increases your recall of information by 20 to 40%. It depends on the type of enacted encoding. It depends on the content of information that you're trying to learn. There are a lot of factors, but 20 to 40% is what most modern research says. Early on, they thought it was as much as 70 or 75%. And you'll actually hear people still cite it today, people that aren't looking at research. You'll hear people say that you learn 75% more if you use experiential learning instead of just lecture-based learning. That is not the case according to modern research, but instead it's 20 to 40%. That's still very significant. And by the way, let me just throw in here one extra thing, that the benefit of this is that it's easier to encode information for lasting recall by doing enacted encoding, experiential learning, by doing enacted encoding instead of just reading a book or just listening to a lecture. It's easier to do this than it is to just do what we call rote memorization. Remember that, sitting down, and let's say you wanted to memorize the four primary cues that are used with WMM, right? And so you're sitting there saying ACVO, ACVI. You're just repeating them again and again in your brain. ACVO is voice, ACVI is video, and you're just stating it again and again. Well, it's actually easier to pull up a protocol capture, look at the frame, and look at the WMM parameters, and then just walk away. And then later on, pull up a different capture and look at that information again. That's enacted encoding. That method, you will remember it far better and far longer than just sitting there trying to do rote memorization. Rote memorization is really good for short-term recall, but it's not good for long-term recall. You lose that later on. The enacted encoding gives you much better long-term recall. And there are different methods of enacted encoding. We have motor imagery. This is what I was talking about earlier, where I said you're just visualizing the information in process. And let me give you an example of this. You could literally close your eyes and imagine the four-way handshake, right? So you could imagine the first message going through the air, and you could see the message and the types of things that are in that message going through the air. That would be motor imagery. You're imagining a physical thing occurring, even though in the real world you'd never be able to see the actual message going through the air. The amazing benefit of the human imagination is that we can visualize that, and that would be motor imagery. That would be better than just trying to do rote memorization, saying to yourself again and again and again what is in message 1 versus message 2 versus message 3. And then you have observation. And observation is where you're watching someone else do it. So imagine you're watching an instructor teach CWAP, and they're bringing up captures on the screen and showing you the frames and showing you the bytes and bits and explaining what they mean. That would be observation. Now, that's better than just trying to memorize from, say, a book that lists the bits and what the bits mean in each frame type. Okay, so observation is a form of enacted encoding. The theory in learning is that, our brains can't do much to tell the difference between something we're observing in reality and something that we're just imagining. And this is why both motor imagery and observation are similar in their capabilities, but they're going to be toward that lower end with enacted encoding. They're going to be down toward that 20% improvement over semantic encoding, which again, remember, semantic encoding would be a verbal lecture or just reading. The best one generally is self-enaction. Okay, the best one is self-enaction. Now, they are very similar, though. So again, 20 to 40% variance between these, but there's more variation with age. As you get older, self-enaction becomes better and better for you in most of the research that we find. So self-enaction would be, instead of watching an instructor go through a PCAP file, you download a PCAP file and go through it yourself. And what you're doing now is you're engaging your physicality with it. And the research has again shown, no matter what we're learning, when we're physically involved during that learning process, it creates stronger neural pathways. Amazing research out of 2007 through 9 showed with fMRI imaging the stronger neural pathways being developed when we're doing self-enaction. We're physically active while learning something, as opposed to being sedentary while learning something. So it's an improvement over either motor imagery or observation. Interestingly enough, in one research project, they actually showed that you could just be moving your hands while you're doing motor imagery, and you could boost even more the enacted encoding of motor imagery, because again, that physical involvement is there. So some really cool stuff there. All right, we're going to wrap this theory section up with free recall versus cued recall. Another thing in the research again shows that, and this is interesting because it's the opposite of what you would expect. Free recall is not as good as cued recall for long-term retention of information. Now, what do I mean by that? Free recall would be if you sit down and you simply say, all right, I want to verbally out loud say everything I know about the four-way handshake. Cued recall would be, you've got a list of questions about the four-way handshake, and you're going to answer them. So, for example, it might be something like, what is uniquely in frame three, message three, that is not in the other four, or the other three messages? So that would be a specific cued recall. You're looking for what's in that message that's definitely not in the other three. Or explain why the frames are different for each of the four messages in the four-way handshake in a PCAP file, right? That would be cued recall. And most of the studies in this have been done with K through 12 education. And an example that might be in that kind of arena that will help you understand it is, instead of a teacher saying to a student, "Tell me everything you know about World War II," the teacher would instead say to the student, "What was the catapult that brought the United States into World War II?" Or what was the key to the ending of World War II? That kind of thing is telling the student to focus in on a very specific area. That is cued recall. Interestingly enough, you find that weeks and months later, people can, if you do ask them to dump everything they know about World War II, they can dump much more information if during the learning process, cued recall was used to learn rather than free recall. And they even better retain information they were not cued upon. So that's really cool. So what am I saying here? Well, in your lab exercises, you need a list of things that you want to go discover while you're learning. So go find out what happens when you change this setting, and then you go and find out what happens, and you explain that to yourself effectively, whether you're just doing it in your mind or if you're doing it out loud. I really encourage you to do it out loud. That might sound strange, but there's research that shows that when you hear your own voice explain something, you actually retain it better than when you hear someone else's voice explain it in exactly the same way. I guess, my theory on that is we all arrogantly think we're the best explainer, but whatever causes it, it's a phenomenon that does occur. So certainly something to look at. All right, so let's do a little demonstration exercise together. You're observing, I am self-enacting here, but we'll take a look at this. So what we're going to do is we're going to look at the four-way handshake. I've brought it up a couple times, and I want to use it as an example. And so let's say I went into my lab and I captured the four-way handshake. I'm learning about it, and I want to understand how it works. Well, the mistake I think a lot of people do is they capture a four-way handshake. And this is an older one, by the way. This is just one I grabbed online that someone in their blog post, they shared through CloudShark, this capture publicly available. So I just grabbed it because it was easy to show you today. But the point is that people will capture it, and then they look at it and say, "Oh, there it is. There's the first message, second message, third, first, fourth message. Oh, great. Yeah, okay." And they move on. They haven't actually learned anything. They already knew there were four messages. After all, they were capturing the four-way handshake. So they already knew there were four messages. What you want to do is take advantage of this to really drill down. So you can look at different things. Like one of the key things that stands out to me when I look at this is look at the length of these four messages. The first two are 155 bytes. The last one's 133. The third one is 189 bytes. So it's significantly larger than the first two, and even more large in comparison to the fourth message. So here's the question. Here's my cued recall. Why is the third message so much bigger than all the others? Right? Now, what I want to do is I want to try to answer that from what I've learned so far already. And I'm not going to give you the answer right now, but I'll reveal that in a moment if you don't know. Some of you already know. If you know the answer already, hey, go ahead and put it in the Q&A. Tell us why the third message is so much bigger than the others. But the point is, maybe you know the answer from your research already and your learning. If you know the answer already from your learning, what you're doing right now is you are encoding this knowledge better in your mind than it was just by whatever method you used to learn it already, whether that was observing a trainer who lectured on this, whether it was reading a book, listening to a podcast, whatever method you used to learn about the four-way handshake and these four messages. The reality is that you're now encoding it more deeply by going through this experience and then asking yourself the question, why is that bigger? Well, I want to investigate this. I want to go deeper into this and figure out why this is bigger. So the first thing I'm going to do is I'm going to look at the first message here, and I really don't care about this stuff up at the top. I want to look at this detailed information about this. And so I'm seeing that we've got our information about our nonce. So there's our number used once. Great. I know that that's part of the four-way handshake. I'm also, guess what? I'm also ingraining that deeper into my mind. The nonce is part of this because I'm seeing it right here in a different way. You know, if I looked at a book and it gave a flow diagram and there was just a little square that said the message from the AP to the client has the AP's nonce in it. And then I look at the next message and I see that it also has the nonce, and I say, okay, great. The message from the client to the AP has the client's nonce in it. So all I'm doing is I'm noticing that right here in the file, what that little square told me is right there. It's in the actual message. I can see the nonce being transmitted. And so the point is that I'm gaining that information, but I'm seeing the interesting thing. One thing that just jumps out at me here is down here the key data length. See that? It's 22 bytes. So it's 22 bytes there. It's 22 bytes there. And I'm going to cheat. I already know the end, but I'm going to skip over the third message and go to the fourth because I'm wondering if maybe I've gotten onto something here. And now I see the key data length is 0 bytes. Interesting. So it was 22 in the message 1 and 22 in message 2. And now it's 0 in message 4. I wonder what the length is in message 3. Ooh, look at that. It's 56 bytes. So what's the difference between 189 and 155? Well, the difference there is 34, isn't it? Well, what's the difference between 56 and 22? It's 34. So the exact difference in the size overall is down to the difference in size of the key length. Interesting. So what do I know related to a key in the four-way handshake that is related to message 3 that might accommodate for that extra number of bytes that's in message 3, making it so much bigger than the other? Well, the answer is that in message 3, the AP encrypts and sends the group key, the GTK, down to the client so that it has that to be able to decrypt group messages within the BSS. So what I know then is that this key data now includes the actual group key. It's in there. It wasn't in the first two, and it's certainly not in the fourth one, which the fourth one effectively ends up just being an ACK to the AP to say, hey, I've got my keys installed. I'm ready to go and start doing unicast encryption with you. So that's really cool and interesting. Now, another thing that you can do in your experiential learning is up here, this whole key information section. In our, excuse me, in our CWSP course, we take this section of the 4 messages apart and really go into the detail. It's just a couple slides, but we go into the detail about what all of these bits mean and when they change in the different messages and so forth. So what you can do is you can take that material and you can look at those bits and what they actually are in message 1, and then what are they in message 2, and what are they in message 3, and so forth. For example, notice the install bit is set to 0 in message 1. The install bit is set to 0 in message 2, but in message 3, look, it's set to 1. And in message 4, it's back to 0 again. See, the install bit is the directive from the AP to the client saying, you've got everything you need now. including the group key that's in this message. So install this stuff and let's start communicating. That's why it's in message 3, because we've come to the point where that directive can be executed to the client or given to the client so that it can actually install this. So that is the benefit of getting in here and actually doing this in a lab environment, because you can come in and you can see the stuff that you've been reading about. And I will guarantee you will remember things massively better when it comes to exam day. But more than that, you'll just remember it better on an ongoing basis. I've had people many times ask me when I teach, like when I teach CWNA, CWSP, AP, DP, CWISA, whatever, they'll notice I don't really have notes and I'm not looking at notes. And I'll bring up a slide that's got 4 bullet points on it and talk for 15, 20 minutes sometimes. And they say, how do you keep all this stuff in your mind to be able to explain it? And the answer is because I understand how it works. And so when you really understand how it works, explaining it is just the process of abstracting that information and layering analogies and other things with it so that people can understand what it is that you're looking at. And so this is the benefit of really knowing this stuff. And I'm just going to tell you, you don't truly really know it until you get in there and start working with it. So that's a key thing to make sure you have that experience. And this is just a simple example here with a 4-way handshake. And again, this is an older one. In this capture file, this happens to even be WPA. It's not even WPA2, but it still reveals the interesting information we're looking for in this case. All right, so let's talk about some devices. I'm going to use the example of the Grandstream GWN 7665 AP. So this is an access point. You can see that it looks like some of the typical kind of round access points that we see out there today. Says it's a powerful enterprise-grade Wi-Fi 6E access point. It is a tri-band AP, so it's going to function in 2.4, 5, and 6 gigahertz, which is a useful benefit. And you can see down here, they say, you can manage your network with a network manager. That's interesting. And then they've got a guide to Wi-Fi communications. Now, if we go into the manual for this series of APs, you'll see there's a lot here. So you can clearly tell you're not dealing with a consumer wireless router here. And that's the first thing that I would say is if you're going to spend a few $100s to get some equipment for your lab, don't buy consumer wireless routers. And what I'm talking about there is, your Asus, Linksys, Netgear, TP-Link, those wireless routers, they're wireless routers. They're not access points. There's a difference. Wireless routers have an AP in them. And then they also have your Ethernet ports for the LAN and then a WAN port, whereas the APs just have 1 or 2 Ethernet ports that are intended to be connected to your network infrastructure, just like enterprise APs. The reason I suggest getting an actual AP and not a router is because they tend to have more and unique configuration options for those radios than what you actually have for those consumer grade wireless routers. Now, in fairness, you can get some consumer wireless routers, and then if they support something like OpenWRT or DDWRT, which is an open source firmware that you can load on those, then you could put that on them and get some more enterprise grade features. But you're not going to necessarily be able to do that with every consumer wireless router. So that's the reason I suggest that. And again, I want to reiterate, I'm not suggesting go get the Grandstream AP. I'm suggesting when you're looking at the AP that you're going to get, don't just look at the price, because it might be worth an extra $30, $50, or $100 to get an AP that's going to give you the features you want to use in your lab. Okay, so when we look through all of these features, you can see that it does have access control features through access lists, time policies, bandwidth rules, and it does support private pre-shared key. So that's interesting. If you want to look into how that works, this is a device that will allow you to look at it. It has captive portals, which is one of Keith Parsons' absolute favorite features in the world. He loves these and feels that they should be enabled everywhere. And we'll see if he's with us today, because if he is, I expect he'll comment on that. When we look at security, you can see that this gives you rogue AP detection, which is an interesting feature that is very useful to be able to analyze. There's a firewall, there's advanced ARP attack defenses, or just ARP attack defense. We've got neighbor discovery attack defense. So there's some interesting features there. Services, it supports Hotspot 2.0 if you want to work with that. SNMP, of course, it's got a DHCP server built in. It also supports L2TP VPN tunnels and TR69 for another standard management protocol. Systems, you've got your basic settings for your LEDs and so forth, mesh operations, scheduling, maintenance, and so on, and then upgrade and restore procedures. So, okay, that kind of gives you some information. You can see lots of pages covering the specs for all the different versions of this AP series. And then eventually you get to the actual manual. Here we go. We're starting to get into the actual manual. So about half of this is just all the spec sheets for all the different versions of this AP. And then eventually you get into the manual itself. Now, moving on, you can see this is just one source, the telecom spot where you can get it. $109.99. Not bad for an AP that gives you these features and capabilities. And then we move on to the next thing that you might look for is what's the ecosystem that the vendor provides. Okay. So here we see that they support switches that are PoE managed switches. And so you could get like the lower cost 8-port version here, for example. Now, these are gigabit switches, and so that's going to limit it in that case. But for a lab, gigabit switch can be sufficient, but do always step back and think, what do I want to do in my lab? Because if you want to actually utilize throughput testing, say for 802.11be devices, Wi-Fi 7 devices, or something like that, and you want to test it across the network, well, you're going to need something more than a gigabit switch if you want to get any measurement of whether you're exceeding that or not, right? Because you're certainly not going to exceed it if you can't exceed it. So you have to think about that. Here's that switch. So $149. So, at this point, we're looking at 149 plus 109 US dollars. So around 260, and you have the AP and the switch, which could work well for your lab. Because one of the things you have is with this particular system, you have what's called their GDMS. It's their management system. And I'm not going to spend a lot of time on it, but it's their centralized management that, as you can see, goes on and on with documentation and allows you to manage your switches, your routers, your APs, everything that you're putting in your lab from a central management environment. And the cool thing is you don't have to pay for the management. You can actually download an OVA file, launch it in VMware Workstation Player, everything free from this management perspective, except, of course, the computer that you're going to run the virtual machine on. And then once you run that virtual machine, you're just going to boot up and start the service. And once you start it, you'll see a typical thing like you see with these web-based services, that it shows you the actual URL that you use to log into it. And then you simply connect to it from remote, and you're in the GWN manager. And from there, you can manage, again, your APs. You're going to get extra things, like you're going to get insights, the ability to do message and packet capture. So a lot of extra features and capabilities. There's even it's not a great tool, but there's a visual simulation where you can load in your floor plan, and then you can place virtual APs, and it does propagation modeling. Don't expect it to be as good as a real wireless design tool, but at least there's something in there where you can look at that kind of thing. Now, again, I'm not telling you to go out and get this particular vendor's product. I'm simply giving you insight into what to look for. Look for the features of the AP. Does it give you what you need to work in your lab? Look for the ecosystem of the vendor. Do they have a low-cost way that you can implement a sort of enterprise feel, and look environment. And that's exactly what this one, for example, does give you. There are other vendors too. TP-Link has some low-cost things. TrendNet has some low-cost things. Ubiquity has some low-cost things. Maybe not as low-cost as Grandstream here, but they have some low-cost solutions as well. So there are definitely other vendors out. I'm not telling you to get this vendor. I'm telling you what to look for to make sure you're getting hardware that'll work for you. Let's talk about some of the other tools you're going to need the environment. Spectrum Analyzer. I still keep coming back to RF Explorer when it comes to a lab type scenario, because when you go up to the multi-$1,000 spectrum analyzers that are out there, yes, they're phenomenal and really great if you're doing the kind of work where you need that kind of resolution and quality in your spectrum analyzer. But when you're building a lab, something like the RF Explorer tools work well. Now, I would suggest that you connect them to your laptop with USB and then use the desktop-based applications to view the spectrum information, because it's going to give you better information and more visible information than just the little LCD screen that you have. But even for troubleshooting in a lot of scenarios, I mean, this kind of tool is all you need for a lot of those scenarios. And when you take a look, you go down through, you can see they have different models. I do recommend splurging and getting the 6G if you can, just because it's going to cover IoT protocols in the sub 1 gigahertz area. It's going to cover 2.45 and even a very small part of 6 gigahertz. I mean, just the very low portion of it. But hey, maybe you're in a regulatory domain where that's all you get anyway. So the point is that it's going to cover some better overall frequency space if you can get the 6G version. So you can clearly see here, it's got a gap there in the middle, but it's covering all of 2.4. It's covering 5 gigahertz. And again, the low end of the 6 gigahertz band is in there as well. So these are low cost. And yeah, RF Explorer is still a thing. And so you can see the prices again. $395 might seem like a lot of money, but just do search on the internet for handheld spectrum analyzers, and you'll see that's not actually very expensive at all for one that covers the significant frequency space that 6G does. But you can do it for a lot lower if you are just labbing. You just want to look at some, what does the spectrum look like for different devices? Well, there's a ton of devices that run in 2.4 gigahertz, so you could just go with the $135 model. And yeah, that could be enough for you if you're on a really tight budget. All right. And then when it comes to packet capture and particularly 802.11 protocol capture, well, if you're on a MacBook, then maybe you don't have a lot of budget constraints when it comes to your lab, because after all, you bought a MacBook. But if you're on a MacBook, then you've already got it built in, right? You've got the ability to capture at least up to whatever PHY level the MacBook version you have has in it. And for labbing, hey, is it great to be that cool person that has the latest Wi-Fi 7 and you're capturing some Wi-Fi 7 frames and you're showing them to the world on your blog? Yeah, it is. That's a fun thing to do. But if you're using your lab for learning how 802.11 works, you don't always have to have the latest and greatest, okay? You can use some older AC even technology. Now, I wouldn't recommend going all the way back to 11N. Yes, you could go to an 11N adapter and probably get one for $19 that would still capture the beacon frames in 2.4 and 5 gigahertz and probe request and probe response frames and other management frames and even data rate data frames that are in 802.11n data rates. So yeah, you could capture and you could still learn with it, but I mean, the cost difference isn't massively high to go up to 11AC. So I would at least go to something like this Alpha AC 1900 adapter. Here's what you want to look for. Before you buy your adapter, go out and do some research online and make sure that adapter is going to work to do the type of capturing you want to do. Now, what I generally recommend is that people go and search for adapters that are compatible with Kali Linux, because if they're compatible with Kali Linux, then they'll allow you to do capture for a lot of different Linux operating systems, but I would be, and the reason I say Kali Linux is there's just a lot of websites that list adapters that work with that, as opposed to searching directly for Ubuntu or Debian or something like that, and then saying, oh, and it needs to be able to do monitor mode or whatever. It's easier to just say which ones work with Kali Linux, because then you know you're there. Now, do think forward a bit, because it might be worth, you may need to spend a little more money, but it might be worth spending a little bit more money, going from say $29 or $39 up to $60 to $100 for the adapter that will also work with other tools. So maybe you want to use acrylic Wi-Fi sniffer, right? Make sure you're getting a tool that works, an adapter that works with that. So there could be some adapters that'll work with Kali Linux, but they won't work with acrylic, right? And maybe you want a tool that'll work with ComView for Wi-Fi, okay? Because you plan to eventually buy that for your lab or even for your day-to-day work. Again, make sure you're getting an adapter that's going to put you in a position to be ready for that. So think ahead, look at other things you might be either spending money on or utilizing in the future to actually do your protocol capture on Windows. But either way, you need a device that's going to give you the ability to capture 802.11 frames. That's what you're after. So, just because your laptop has an 802.11 radio in it and you're running Windows, that doesn't mean you're going to be able to capture the 802.11 frames. You might be able to get a connection to a Wi-Fi network, and then you fire up Wireshark and you can see that there's activity. You capture it, but when you actually look at it, it has built these pseudo Ethernet captures. And really all you have is layer 3 and above. You're not really getting everything. And it's only capturing what you're sending or receiving on your computer. So you're not getting the beacon frames and that other information. So you want to truly be able to capture 802.11 frames. That's the key as you're going through that process. All right, so those are some things to look for. And by the way, if you step back just for a lab type environment, in the real world, when we're troubleshooting with the protocol analyzer, we want to be able to capture at different locations because we want to capture where the problem is in many cases, right? And that means that just capturing in the AP is not always good enough. But in a lab environment where you're learning and testing this stuff, then if the AP that you get allows you to capture the 802.11 frames, that may be sufficient for your learning process, and you might not have to go to this extra level. So think about that too when you're choosing the AP. If it can do 802.11 capture, and even cooler, if it supports remote capture protocols so that you can run Wireshark on another computer and then across the Ethernet network, you can initiate a capture by that AP and then have it live streaming right into Wireshark, then hey, that can be a great way to do it as well. Now, what is the benefit of buying a Wi-Fi protocol analyzer like ComView for Wi-Fi, which for a lab environment is probably the best because it's going to be least expensive in comparison to some of the others that are out there, and it's going to support a lot of adapters? Well, the only real benefit is that they do a better job of representing the frames in such a way that you can more easily understand what they're saying. And they're going to give you all kinds of, visual views of things like retry rates, and they might possibly try to represent SNR and give you charts for that and graphs. So they might give you extra information that they are calculating based on the capture that you're performing that, say, Wireshark alone is not going to give you. So that can be a benefit as well. All right. Now, there are other tools too beyond what we've talked about here today. Obviously, you've got your Wi-Fi sniffers like Wi-Fi Explorer Pro that are originally they were scanners, right? They were just intended to be scanners, but then they became, and by scanner, I mean just basically reporting to you the list of Wi-Fi networks that you see. Think Net Stumbler way back in the day if you're an old timer, right? That's what I mean by a network scanner. So that's all they were intended to be, but they evolved and really Intuit Bits has taken Wi-Fi Explorer Pro just to phenomenal levels over the years. So great tool there that can also be useful as a learning tool and a lot less expensive than a full-fledged protocol analyzer with all the experts and things like that that they might have. Acrylic also, Acrylic, Acrylic. They have quite a few as well that can be beneficial to you as tools. So certainly look around and see what's available in those spaces. Now, the last thing that I want to talk to you a little bit about is using our large language models for your learning process. One of the tools that's available to you, excuse me, is the free Notebook LM. At least it's free right now. Hopefully Google continues to make it free. It's been free for well over a year, and it has gotten new features every couple of months or so. Basically, Notebook LM is freely available with a personal Google account. So if you've got like an enterprise workspace Google account, something like that, then you're going to be limited in that they haven't made this available in that space yet. But just use your personal Gmail account. If you don't have a Gmail account, then create it. Create your own Gmail account. And it's free to create, and then you can use Notebook LM. So just go to notebooklm.google.com and log in with your Gmail account. That's a personal account, and it will bring you into Notebook LM. Now, I've already created a notebook, so the first thing you do is you create the notebook. And the key is that when you create a notebook, you upload sources for it to use. So the benefit of this is it's basically doing RAG for you, which is basically retrieval augmented generation. And so what it's doing is it is taking this information. Well, let me simplify this. Let's say you go to ChatGPT and you paste in a prompt that includes 5,000 words of text. And then after those 5,000 words, you say, based on the text above, explain the following to me. What that does is it gives a context to ChatGPT, and it tells it the context within which I want you to explain whatever to me is the 5,000 words that I just pasted above. Okay. What RAG is basically doing is it's doing that. It's building a context, and then the LLM is looking to see if it can answer the question out of that context. No, let me get the next chunk of context. Can I answer it out of that? No, let me get the next chunk of context. Can I answer it out of that? And it doesn't matter if there are 50,000 pages, it's going to load them in chunk by chunk looking for your answer. Now, how good it does at that depends on the system, right? They're all going to be different. Notebook LM is pretty good, but the problem is sometimes as soon as they think they've found the answer, they'll quit looking. They won't look any further, right? So you might have to at times get explicit with it. Like in mine, you see, I've got an 802.11-2020-01 and then a 020304. What it is Notebook LM, if you try to upload the entire 802.11.2020 PDF file, which is freely available for download in the Get 802 program from IEEE, so you can get it free. You don't have to steal it anywhere. It's absolutely free. 802.11.2020, if you try to upload it as a full document, it's too big. All those thousands of pages, Notebook LM won't accept it. But if you first of all open the PDF and then export, 100 or 200 pages and then another 100 or 200, and you can actually do several hundred at a time, but you export these pages into separate files, and you can see here that I've separated it into 13 different chunks. So I've got 13 chunks out of 802.11.2020, and then I just uploaded 802.11ax 2021 as a single file because it'll accept that size. That file goes in just fine and is processed. So I actually have all of 802.11.2020 and 802.11ax 2021 in here. And you could do the same thing, right? And then once you've uploaded all that, you can simply ask it a question about the 802.11 standard. So you could say something like, for example, what is the four-way or four-way handshake, and what are the four messages involved, and what are the details of those messages. Now, I would normally take more time to be more thoughtful in my prompt, but I'm just going to put that in there and let's see what happens. See if it can come up with an answer for me. So it's going to have to look through that content, trying to find some reference to the four-way handshake. And I did intentionally say the number 4-way or the word 4-way because, hey, maybe I'm not sure. I don't remember which way it says it in the standard. And so I'm trying to get it to get me this information. And I want to make sure that it knows what it's looking for. All right, well, let's see what it has found here. The four-way handshake is a pairwise key management protocol defined in the standard. It confirms that two parties both have the pairwise master key and distributes a group temporal key. The four-way handshake completes the authentication process. That's a pretty doggone good summary. That's a pretty good summary. And then it says, here are the four messages. Message 1, authenticator to supplicant. And you can see these zeros and ones here. All right, that's that stuff. Remember back here, I told you right here, this key information. All right, those zeros and ones, that's that stuff, okay? That's what that is. And then a nonce, another zero, and other information. And then it goes into the details for that one. Then it does message 2 and the details. And then notice all these citations out here, 3, 4, 6, and I can click on it. And over here, it gives me within the text. Now, this is the extracted text that it extracted out for the RAG operations, right? So this isn't the actual PDF file. This is the text that it has extracted out after I uploaded that PDF so that it could use it for this RAG generation of text. And so you can see in context the information and go in and verify that it's either accurate or inaccurate in what it gave you. Now, as I'm sure you can see, had I asked, and you can try it, go ahead and create your own notebook LM, put the 802.11 standards in there, ask a question to that, and then go over to ChatGPT and ask just the exact same question and watch how weak, wimpy, and useless the answer is without this RAG processing compared to having this RAG processing. Now, I'm not going to tell you that Notebook LM gets it right every time. It doesn't. Or it might give you some information, but not as much detail as you wanted. And so you've got to kind of prompt it to get more information for you. And so, like, for example, here's a saved one on HE and 6 gigahertz that I queried it in the past. It's a saved response. And so I said, how do clients locate APs running in 6 gigahertz? And it gives me information. Then I said, what are PSCs, preferred scanning channels? And it gives me that. And then what are the channel width supported? So I had a conversation with it and I saved that conversation for later retrieval. And then you can see others that I had as well. And yes, you've got the podcast. So if you wanted to, you could have this generate a podcast for you. Now, I will point out, I'm going to go ahead and load that so I can show you something here. And what I'm going to do is delete this. And here's a new thing. If you knew that Notebook LM could generate a podcast, so what it is it looks at all of this information over here, your sources, and it generates a podcast. The podcasts they're decent. For this many sources, I have no idea how long it would be. It would take it too long to process, so I'm not going to do it live here. But I do want to show you, if I click customize, this is a new feature they just added in the last month or so that allows you to go in and give it directives. So you could say, hey, using these sources, generate a podcast that just explains the four-way handshake. Go into excruciating detail and explain every single bit in the message. You can give it that kind of directive and you can get a very detailed quote unquote podcast that it generates for you. And you can then use that as a learning tool as well. But again, I want to encourage you, anything that LLM generates, always validate it because LLMs are not always right. Okay, so you want to make sure you validate it. Now, one final thing that I want to mention here before I wrap things up today, and that is one of the powerful methods that you can use when it comes to uh, enacted learning or experiential learning or encoding information through action is create your own things like explanatory notes. So don't just highlight. In fact, there's all kinds of research that shows that highlighting stuff in a book doesn't help you remember it. It might help you locate things you might have been interested in later on when you go back to that book, but it doesn't help you remember it. So highlighting is not what I mean. I mean, create your own explanatory notes. And what I mean by that is write it out in your own words. Don't just write what is in the book or what the speaker said. When you're taking notes, always rephrase it into your own words. Research shows us that's a much more powerful way to store the information. Now, you want to make sure what you're writing is correct, so you'll want to validate that information by questioning the instructor if you're in a live class, by comparing what you've written with what it says and saying, yes, I've said the same thing. Frame representations. So create your own frame representations instead of just looking at the ones in a book or on the screen when an instructor is teaching. Draw your own while you're going through that learning process and create your own diagrams. You can literally create diagrams of your network structure. You can create your process of communication flows on the network, how they communicate, hierarchies, like, for example, what happens at the layer of the controller versus the AP versus the client, or hierarchies when it comes to encryption keys, what keys are derived from what other keys and what other information sources and so forth. So write them out, diagram them. Research has shown that that is as effective as doing things. Because what are you doing? You're doing something, right? So create your own explanatory notes, draw your own 802.11 frame representations. And here's a really creative thing I found to be very, very powerful. You know how the frame representations in the 802.11 standard and in most of our materials and most other learning tools, when you're learning about, an Ethernet or a Wi-Fi frame, they have little squares with labels on them, and maybe above it it'll say how many either bits or bytes or octets that section is, right? And then they might break it out and say, okay, now this one field is broken out into these subfields, and here are all the bits in there, and here's what they mean. So that's the typical way to represent it. And it's probably a pretty good way. We've been using that method for about 40 years now, so I'd say it's probably a pretty decent way. But you know what? You can also come up with your own way, your own creative way to represent the bits in a frame and what those bits mean. And just the process of coming up with your own way of representing it can then help you retain that information better and make it more memorable. So there's a lot of great things that you can do, tips and tricks to help that learning process. And with that, let me say thank you.